Cool. Well, hello, everyone. Thanks so much for joining us for our panel today on ML observability in fintech finance organizations. We have an awesome group of panelists joining us today. So I'm going to kick off a set of introductions and we'll dive into it. So first up, we have Zach, who heads data science over at Clearcover. Zach, do you want to say hello, give a quick intro?
Yeah, sure. So I'll just say a few things about my background. I was my first career, I was an academic. I was a philosophy professor, associate professor of philosophy for about 10 or 12 years. Quit, went into tech, and I've been working mostly with startups, mostly inside startups, including at Clearcover, which is in InsurTech, and mostly around data engineering and helping to get data science teams up and running. Before Clearcover, I spent a year as a principal data engineer at McKinsey & Company. I've done a little bit of work for the National Laboratory System and a few other sort of government-related things. But currently, I'm at Clearcover, sort of helping jumpstart our machine learning efforts and capabilities there.
Awesome. Thank you so much for joining us today. We have Sterling, who runs data engineering over at Divvy. Sterling, you want to say a few words to introduce yourself?
Sure. I'm a data engineering and machine learning engineering manager over at Divvy. I've worked in like 5 years from the ground up in data directed positions. Started out as an analyst who needed to build out BI pipelines and help report on machine learning model performance. And then worked my way into a data scientist role. Had to learn how to understand the business needs and how to translate them into a model and assess if the model was meeting those needs. I formed a team of machine learning engineers and have firmly believed in pairing a machine learning engineer with a data scientist to deliver business value. And that led me to my current role, where I started out as a data engineer and then became the data engineer manager, and somehow was able to finagle it into a machine learning engineering manager too. So.
Awesome. Thank you so much for that. And then Brandon, we have Brandon who's joining us over from Square. Do you want to give a short introduction on yourself too, Brandon?
Sure. So hi, everybody. My name is Brandon Duderstadt. A couple years ago, I was pursuing a PhD in biomedical engineering at Johns Hopkins. And during that time, I got an awesome opportunity to join a startup called Rad AI. They just raised $4 million from venture, which is from Gradient, which is Google's venture fund. So I moved across the country, dropped out of the college program to go there. Worked there for a little while, helped them raise another round, helped them productionize some research models. And then I wanted to round out my experience a little bit with some time at a bigger tech company. So I now work on the language team at Square.
Awesome. Thank you so much for the intros. That's awesome. So I'm really excited to dig in today because I think that each of you have different perspectives on, really making machine learning and successful in production. And, for some of y'all, you have tons of models you put into production. For some, it's, the journey of bringing the first model into production and a lot of insights learned from that journey. What from your background experiences, what's the most difficult part in your organizations today and your past on actually getting that model live in production, actually making it successful in production? Zach, you want to kick us off?
I was going to say I can certainly say something about that. There's all the technical issues. There's all the issues everyone's familiar with around data engineering and data munching and getting the right data in that 90% of the technical work. People always say that's data engineering, and people are right about that. In my experience, I've been working with companies that have just started this journey of getting, these are not places that have a lot of institutional know-how about data science. And so there's a gigantic amount of communication effort. There's a gigantic amount of alignment, expectation settings, sometimes reorganizing the org chart a little bit, establishing new lines of communication, and getting everyone to the point where they understand, why machine learning is being used, how it's likely to change their jobs, what they need to do in order to partner with the machine learning team, and then also understanding what's the follow-up after that. How are these things being tracked? How's business value being monitored and tracked? How do people get to the point where they have confidence in what the machine learning team has built, even though they don't come from that background, and they're not going to, it's not fair to tell them to acquire that background, right? They're going to stay within their silos, within the business for the most part, or within their domain knowledge. But how do you get them to the point where they feel empowered to understand that? I think if I
Got it.
I totally agree. I think that first part that you talked about, Zach, the data engineering is where 90% of the work happens. I agree with that. But for me, the biggest pain point has always been getting it across the line, giving that shove in the validation phase. So there's like a few different types of validation that you have, right? But selling the business on why this is important is always difficult. When you can sit down and have a discussion with other people in the language of statistics and for them to actually understand what it means, you're able to sell them a whole lot easier, because then you can cite model performance. You can cite bands where things are underperforming and that you've actually caught that. But how does that translate to business value? That's always been the hardest part for me. And then as soon as it gets into production, then how do you actually maintain that it is meeting that business requirement? So the model is only able to understand what it's seen before. Is that actually reflective of the data that is coming through in production?
So you think there's almost like two components of what I'm hearing, right? There's like, the technical piece, which is hard, but it's like selling the organization that there's a value add. And even within selling the organization, there's kind of a piece which is the kind of model validation, validating that what you're actually going to put into production makes sense. How do you do that today? Is it on some old teams that I worked on, data scientists would give us a presentation, we'd all go in, there'd be a PowerPoint, they'd walk us through why this new version is better than the old one. And it's a lot to ask people who don't come from that, deep statistical background to understand in half an hour why this is the next best thing. How could that model I don't know if you guys have thought about, how could that model validation process be easier? Or do you think that's just a necessary part of, making orgs more technically, aware of what's going on in ML teams? Brandon, you can take that if you want.
Sure. I mean, so in terms of model validation, I would say one of the biggest challenges right now is getting people to understand how bootstrapping with models really works. With most models nowadays, the first thing that you're going to deploy is probably not going to be perfect. And in fact, nothing you deploy is ever really going to be perfect. The real world is very messy. But once you get a model out there and you have observability in place, you can collect data on what kind of mistakes it's making, and you can start to iterate. And once that cycle of iteration has churned a few times, that's when, in my experience, I've really seen value starting to get generated, which is like, okay, this model's observing things that are happening in its real use case, and it's sort of being trained to correct itself on that. So getting that feedback loop in place, getting past that first step that we mentioned earlier, I think is really critical.
Got it. And because you bring up feedback loop, in a lot of the organizations we talk to, sometimes that feedback loop doesn't come back instantly, right? You don't know if the model is accurate 60 seconds after it made the prediction. It could take 6 months. How are people supposed to, close the loop on a faster feedback loop if sometimes you don't get the ground truth or the actuals back for 6 months? I mean, it's so hard.
Difficult problem, but the best you can do is just tighten the loop, right? Like models that we have nowadays learn because they're getting corrected from examples you have, 100 times a second, right?
Yep.
So the shorter you can make that feedback cycle, the faster you're going to see this model really turn into something that has a real world use case.
Yep. Sterling, go ahead.
I think a lot about how first you need to frame this in forms of, this is science, right? You need to approach it in terms of an experiment. You need to understand the real world implications of your model's decision. And you need to exercise caution in those areas where you're afraid of making the wrong decision. So I always preach, you need to have a roadmap for what your iterations need to look like, and you need to have a slow and cautious rollout procedure for this to happen. You need to establish guardrails on your metrics that establish success and failure. And really, especially in greenfield opportunities where you deploy, you need to be very, very careful and lean towards manual review as opposed to wholesale denials, because you're changing the underlying data that's going to feed back in. So that's one thing that I think a lot about.
Yep.
Yeah, and I would add on to both of those. I certainly more than agree. Also, in the particular business I'm in, the feedback loop is really, really slow. It's 60, 90 days, very frequently. And so that's where it's really important to bring in other stakeholders, because often you can find something that's a faster part of that feedback loop that's a proxy. Like if you're measuring customer churn over a 6-month period, you don't want to wait 6 months. Is there some observable behavior about those customers that will at least tell you that you're on the right track? That you can, maybe you can get at that within a week or 2 weeks or 1 month, which is, a fast improvement. So that's where you get this, this necessity for kind of vertical alignment within the machine learning team or data science team versus the business stakeholders and domain experts.
Got it. Okay. Who in the organization, do you think, if you were to think 5-10 years in the future, who do you think in the organization is going to be responsible for owning that model in production? Is it, there's almost like two schools of thought today. Sterling, you brought up that you tie together a data scientist and an ML engineer. And so in some orgs, maybe that is the relationship. There's always going to be a data scientist who builds the research model, and there's an engineer who productionalizes it. And there's other schools of thoughts, like Google, for example, does the whole you build it, you own it. There's a full stack data scientist. Every data scientist is an engineer. Who, if you're to think about, I don't know, five years in the future, maybe not 10, do you think we're going to see maybe both, maybe more leaning towards one approach? Where do you think, who's going to ultimately end up owning the model in production?
I really like the specialized approach. I really like having someone with an eye towards code quality and understanding production services and making sure that it's fast and reliable. And if something goes wrong with that in the middle of the night, it's the engineer's responsibility to get up and fix it. Yep. But the data scientist that's in the name is the scientist. He is in charge of the business impact and understanding how this thing will contribute towards the business's success. Is it meeting the requirements of that thing? So he needs to be keeping track very closely on the metrics and understanding at which observable points in time he can make a determination about, is this good? Is this bad? Do I need to pull the levers in order to change this experiment? You can go with like set points in time. You can take a Bayesian approach, however you want to do that. But that's a whole person's job. And thinking about the reliability of like the service and the code is a completely different skill set.
Yep. Brandon, what do you think about that? Because if I remember, you've done a little bit of both. You've done both the building and you've done the productionalization and the operationalization of machine learning.
Yeah, so my experience might be slightly different because I did a lot of this as a startup, and so everyone's sort of doing everything all the time. Yep. But I think the biggest thing is just having a documented owner, right? Making sure that there is, headcount and time that's devoted specifically to model observability, model validation. Because if you're not looking at observability, you're not looking at what's going wrong, you're never going to get better, and that's a really big problem.
Got it. Zach, any thoughts on who do you think is going to own it?
Yeah, I mean, I think about the ownership as being kind of divided up. As I don't think of someone as owning the whole thing. Yeah. If you're talking about the engineering and the the reliability, speed, performance, and so on, after it is known to be working properly, at least for a while, then maybe an SRE team or DevOps team owns that, or an infrastructure team owns that. If you're talking about things like model drift and so on, I would expect the data scientists to have a regular role in that, or they should at least have alerts that are showing them that applying statistical tests. But also, I think there's a place for the people on the business side to have some ownership of it too, because they can do things on the business side that will cause dramatic changes to the model performance. If they open up another channel for acquiring customers, and those customers are really different from the customers you've got, I think that's not the data scientist's job to alert that. Maybe it's their job to detect it if it happens, but I would like to see someone on the product side, for instance, with their finger on the pulse of that sort of business decision that impacts the model performance.
Got it. Okay, that makes a lot of sense. One other question for you on kind of the model validation and model in production. has there ever been a model that, because we hear this a lot, data scientist, researcher builds a model moves into production, completely different, doesn't perform as expected, vastly different results. And, I saw this a lot in some of my old positions. And, in that case, maybe the engineer is the one who productionalized the model. Maybe she was the one who actually, deployed it into production. And then you have the data scientists who actually maybe built the first original research approach. Who in that case, I think that's where I'm getting at with kind of my question of moving from model validation to model in production. Do you think that there's always kind of a dual owner then in kind of this world where you have data scientists who's maybe more on the research, engineers more on productionalization? There's kind of two people who are responsible for moving it from research to production.
Yeah, I mean, I can take a stab at that. I think if you get to a failure mode I've seen, and frankly that I've taken part in, is that the data scientist creates the model under the assumption that they understand the business. Yeah. And they understand the metrics and so on, and they understand the meaning of the data. Like I once did a project where I needed to calculate the total sales per customer, and I added up all the things that the customer. And I thought, well, obviously that's right. It was completely right. It was like 8%. There's different definitions for different purposes. And so if you get to the point where the model's been built and been deployed, it's too late. At that point, you're cruising for a bruising at that point. And so I like to see business people in there before one button has been pushed on a keyboard, helping the data scientist to understand the terminology, the data sources, where this data came from, what's happened to it, what transforms, what criteria is being used, and so on. And that, that's a classic case of, a penny of prevention, right, versus a pound of cure, right? If it gets much farther than that, then you're going to be climbing a mountain of technical debt. Basically.
Yep, that makes sense. Makes sense. Any other thoughts on that from Brandon and Sterling?
There's like 3 phases of validation that I think about a lot. First being the data scientist validating that he's solving the business problem in a way that the business is on board with. The second is productionalizing that version. And that's usually the machine learning engineer taking the data scientist's model and validating that what they are deploying is accurate to what the data scientist researched. Once they deploy it, you then validate that the model is performing in production as intended in the way that the data scientist researched it, the machine learning engineer replicated it, and now the business is actually able to use it.
Yep. I like the way you said that. That's a really good framing. All right, I got one last question for you guys before we kind of wrap this up. There's been a lot of discussion in the last couple of years about, ethics in machine learning and in artificial intelligence. And, probably one of the most, commonly, industry that actually uses machine learning is probably in the fintech, insurtech, finance organizations. Did conversations about, model ethics, transparency come up in the development of the model in your day-to-day? Do you think that, we just got off of a conversation where, we were talking to someone who focuses on AI ethics, and she was saying it's a lot of responsibility to put on the practitioners. We need more people involved earlier in the conversation. Where do AI ethics, to you guys, play a role in this, have a role in your day-to-day? And who do you think who do you think should help drive that or push that as models become more prevalent in society? And Sterling and Brandon, do you guys want to kick this one off?
Sure, I'll kick it off. To answer your question, any room that I'm in, those people usually have to listen to me blabber on about the ethics of machine learning. I was just on a call yesterday where I was going over with one of my data scientists that I talk to frequently and asking him how this decision coming from his model is going to impact the end consumer. Is there a way for the consumer to actually correct the behavior? And if it's incorrect, like, you have to think about that in fintech especially. I mean, Divvy is an expense management company that gives out credit cards to businesses. If we deny a business there's real life implications. If we think that they are going to be a poorly performing customer and treat them as such without them having the ability to correct that and for our models to get that back in the loop, they're going to go on and continue to be treated like this. That's one thing that I definitely think about. And the second has to do a lot with the data sources where we're getting our information. Is there historical reasons why some of the data may not be reflective of fairness? So again, the model only knows what you've shown it. It doesn't come up with observations by itself. They're in that underlying data. And unfortunately, in some of these historical institutions, they have not been fair and they have actually been biased. Yeah. So you need to take a careful eye towards the data that you are including, or else you could be propagating institutional unfairness in a real way.
Yep.
Yeah, I think this also goes back to what we were talking about a bit before, with having business people involved a bit more sort of in understanding these models, understanding the deployment. AI models are powerful engines in a way. They're powerful tools, but you have to use those tools for ethical means. And that becomes a tough conversation that sort of, the engineering realm is becoming more cognizant of it. You see conferences like NeurIPS now forcing you to include impact statements with your papers. But it really is also a business decision. And so you need to make sure that there is representation at the business level in your organization to make sure that these tools are being used for ethical ends.
Yeah,
totally. The other piece of this, I think the purpose and the inputs to it are like this, obviously correct. And one more thing to add is that I think this is the killer application for explainable AI. It's understanding the ethical levers that this thing is pulling. So, it's extraordinarily easy to feed in data and features of your data set that you think are completely innocuous, and the model performs well. And then if you look at it from a kind of explainable AI perspective and sort of back engineer how the model's making those decisions, you realize it's creating a portrait of certain racial group, ethnic groups or certain geographies or so on, where you would never, no right thinking person would ever make decisions in that fashion. But you can construct that sort of unethical whole out of very well-intentioned ethical parts, so to speak. And so that's when people start thinking about explainable AI, that's super important. And be a part of I think organizations that are doing this right have a formalized process where there's at least feature importance. There's whatever technology the model enables should be used to document why the model is doing what it's doing from an explainable perspective, and that needs to be publicized and put out there and open for discussion.
Yep. Thank you so much for that. That's super helpful. I think talking about especially ethics and fairness and bias issues, a lot of it feels very not concrete. When you read about it in the papers, you read about it in articles, you're like, what does this mean for the practitioner? How does a practitioner actually apply these? And I think that, it's really heartening and interesting to hear that you guys think about this. There's formalized process for this. And, engineers are helping kind of shape that conversation with the tools that we have. So with that, I just want to say thank you so much, Zach, Brandon, Sterling, for joining our panel on ML observability and fintech. It's been awesome hearing all of your different inputs. Any last words from any of you? Otherwise, we'll wrap this up. Cool. Well,
I just say thanks for a good discussion.
Thank you. Yeah, absolutely. Thank
Agreed.
you.
Thank you very much.
Awesome. Cool. Well, thank you, everyone, and tune in for the next panel soon.